And welcome back. So once again, we are continuing with the train patch. And in this video here, we're going to get a little implementation code in place.
Right. So before we get directly into the get vertex data, I want to get our train generator set up because right now we haven't been using this train generator and we're about to use it. But to use it, we actually have to fire it off, get it created so it's ready to be used. So to start off with, I'm going to go ahead and throw it in our train demo for now. And I'm going to make it a public static. So public static, oops, fat fingered the caps lock again. And so this will be our train generator. I'll call it train generator, very original. Inside of awake, let's go ahead and initialize it. So train generator will equal a new train generator. So we'll get that initialized. So now we'll be able to use it inside of our train patch. So now, get vertex data. What is this method going to do? Basically, just what it says it's going to do. It's going to be the method that is going to go out and get the height information for our vertices. We've already created our baseline mesh, which has all of the positions for our vertices, but all of the Y components of our vertices are locked to 0 right now. Now, this method is going to change as we implement more and more of the system. So right now, it's going to directly go to the train generator to get the height information. But as we bring the vertex cache in, it will go to the vertex cache to get that information. And then the vertex cache will initially go to the train generator to get information, but then eventually it will go to the data store itself to get that information. Again, just this is very dependent as we develop stuff. So as more systems come along, we will be going back and revisiting a lot of these methods.
Right.
So let's go ahead and initialize each of the vertices. We'll do that using a loop that will look at our mesh dot. Yeah.
I didn't say anything.
I meant to do that.
I know you did.
So, I don't want people to think I'm going against my standards. All right, so we're going to go ahead and loop through each of the vertices in our mesh. From there, we're going to need to be able to get a position, or basically a key, to look up information. If you remember, the way the mesh is set up, we are defining all of our positions for our vertices relative to the origin of the mesh itself. The mesh is built with the origin of the mesh at 0, or 000, the world origin. So if we don't do any sort of translation of the vertex information, all of our meshes are going to have the exact same information applied to them. So we're going to have to make a couple of helper methods that we're going to be able to send off a vertex location and have it translated to world position based on the location of this particular patch. Now, the naming of these two methods are a little bit unusual, mostly for the fact that the way I have named them, or the way the naming is unusual is because I named them based off of the fact that they are literally building the key that we look up in the vertex cache. So the names of these methods are get key. So don't let that throw you. The reason it's called get key is because the vertex cache is looking for key information. So because it uses a dictionary. So these will be, I'm going to make these public methods. So we'll do a public vector 2 version, and then there'll be a vector 3 version. So we can pass in either a vector 2 or a vector 3, but the key that returns will always return a vector 2. So we'll return a vector2, call this get key, not get ket. Well, get ket. Interesting name. All right, so this will be vector2. We're going to pass in a position, and from here we'll do the calculations. That will be var x equals. Now I'm going to do some rounding here because when I was doing some experimentations with the miniaturization of this world, I found that rounding errors will, when you're doing a comparison of x to y, or x a to x b, those rounding errors can be significant enough that you're going to return a false, even though when you look at the floats, they look like they're exactly the same. So what I'm going to do is I'm going to round our positional information to 2 decimal places so that when we do the floating point comparison, they will equate and won't return a false negative. I hope I said that right. So we'll take position x plus world position dot x, and I'm going to round it to 2 decimal places. So basically, this is what's going to handle taking our vertex position, its local position, and translating it to a world position based on the position of the patch itself. And then we're going to round it to 2 decimal places to ensure that when we do a comparison, we're not going to get the false negative, meaning if something was 1.0000000, the other one was, .100000001, and then it goes, nope, those are different when they should have been the same. Or at least as far as we concerned, they should have been the same, because our patches aren't going to need that much precision for positioning them. So, and I'm going to cheat. And this will deal with y. And the reason why it's dealing with y and not z is because these are vector 2's. Then once we've calculated those, we will return a new vector 2 of x by y. Now, our second variant of this is going to be pretty much the same, but we're going to pass in a vector 3. And then we'll return what comes back from get key, but we'll massage the data so that we're passing in a vector 2 that contains position.x by position.z. So that will give us the ability to pass in either a 2D vector or a 3D vector, but we will always get a key that will be a vector 2. Because as far as looking up height information, we don't really care about y information. We only care about x and z to get the position in the world of that. Our algorithms and our train generator will take that information and figure out what the height will be, and that's what we'll use to set the y component of these vertices.
Okay.
So now that I have the helper methods, I can go ahead and create a variable called key, and that will just be simply whatever we get back from get key. And in this case, I can pass in mesh, make sure it's the right one, dot vertices dot do I want dot? No, I want element I. This is why we have the 3D version, because vertices are a vector 3. So I can pass in vector 3's directly and then get the right information back. Now once I have that information, I can go ahead and position our mesh. Vertice based stuff. Yeah, whatever. All right, so we can position our vertice sub I, set it equal to a new vector 3, vertex, not vertex because we don't have that information, but we can use our key dot x, and right now I'll just type in height, fill that out later, and our key dot z. So we know that our vertex information is going to be the same, but what we need to figure out is going to be, oops, sorry. What we need to do is figure out the height. So to get the height, we'll just do var height equals, now we'll go to TerrainDemo dot grab the TerrainGenerator, and inside of our TerrainGenerator we've got get smooth height. That is going to take an x and a z, so this will be key dot x by key dot z, or key dot y. I do that all the time. All right, so basically all we're doing is we're generating a key, and this will give us the positional information that we need to send into the train generator. And we're only doing this temporarily until we get the vertex cache in. Once we get the vertex cache, we'll query that as opposed to the train generator directly. We'll get our height information. We'll then reassign the position of the vertices in the mesh to include our new height information. And then that will give us the height information of our vertex data, which is this part. Now, the next part that we need to do is to go ahead and set up the mesh details. These are going to be the things like normals, colors, and tangents. And we'll flesh that out, even though it's really not going to do anything for us yet until we have the vertex cache in place. But we'll set that up in the next video. There's also one final method that I want to cover, which is going to be the recycle, and that will handle when we are done with the mesh and taking care of everything that needs to be done to put the mesh away until we need it again.
Okay, cool.
So we'll cover that in the next video.
Okay, well with that, that is going to wrap things up for this video. Thanks a lot.